Okay, today we're going to solve a question on Schmertmann's method, yeah, in granular soil for settlement. So we will try to solve the question using this equation. So we have to calculate each parameter. So we have C1, which is a parameter for the shape, or sorry, for the depth of the foundation. And we have C2, which is the time parameter, yeah, the correction factor for time. And we have to calculate the IZ over ES delta Z. So sometimes you're given ES diagrams, and sometimes you're given QC diagrams, yeah? And we have to know the difference. So basically, when you have a QC diagram, you have to apply these formulas, yeah? For a square footing, you have to basically get an ES diagram at the end of the day. So sometimes they give you an extra step and they give you only QC and you have to calculate ES by these formulas. If you have a square footing, it's ES equals 2.5 QC. If you have a strip footing, you're going to use this formula, which is ES equals 3.5 QC. Yeah, but sometimes you're given ES outright, which then you are ready to basically go into these diagrams. So the first step we're going to do in our question later is to do the QC, turn it into ES. But usually, or sometimes, it doesn't have to be the case when you're given ES outright. Okay, now we have to talk about this. So basically, when you have a strip footing, you're gonna basically use this chart, and when you're given a square footing, you're going to use this chart, yeah? So basically, you'll have to calculate IZ max, which is at depth Z equals B. And basically, you are going to be given many points under the foundation. So you have to calculate something we call the depth of zone of influence, which is Z2. Z2 for strip footing equals 4B, and for square footing, it's 2B. Let's go to our question. Our question basically a continuous foundation on a deposit of sand layer shown in figure 9.10 along with the variation of the cone penetration. Okay, so you're given cone penetration QCs. Yeah, so now we have to turn the QCs into what? ESs. Yeah, the time is 10 years. We have gamma at 18. Yeah, to get things out of the way, basically, I'm going to do two things outright. I'm going to calculate Q, which is equals by our thing, Q equals gamma times the depth of foundation. In our question, the depth of foundation is 1.5. So it's going to be 18 times 1.5, which equals 27 kilonewton per meter squared. Yeah, we got that out of the way. And now we're going to basically calculate the ES for multiple layers. So I'm going to draw something like this, like a chart. Or first, let's get the depth of zone of influence. So Z2 equals 4 times B. And B in the question, as we could see, is 2.5, which means we have a 10. So the depth of zone of influence is 10. We have a table like this. We have from 0 to 2, our Z. Okay, let's be professional and write Z. So we have like a nice little table. Z, or delta Z, or whatever, yeah? QC ES through the transformation of this formula. So we have three depths we have to consider. Why? We have three zones of QC. Yeah? So we have first from 0 to 2, Y, this is 0 and this is 2. So it's going to be 3.5 times QC. So 3.5 times the number here. So 3.5 times 1750, which equals 6125. And we have from now what? 2 to 8. So from 2 to 8, we have 3.5 times 3450, which equals 12,075. And now we have what? Now from 8 to the depth of my zone of influence, because whatever is under that is out of my concern, right? So 10. Because the zone of influence basically is the foundation's zone of influence. So whatever is under that is basically out of my zone of influence. It doesn't affect my design, basically. So it's going to be what? 3.5 again, multiplied by 2,900, which is the number for the third zone, equals 10,150. Yeah. Now I am ready to basically start. I am ready to start drawing this, basically. But I have to calculate a couple of things first. So I have things that I could do given a formula. So I have to do IZ max first. So I draw in one go, which is this value, yeah? IZ max. The formula is 0.5 plus 0.1 squared root Q bar minus Q over QZ1. Now QZ1 is the only thing I do not have now. But I know that QZ1, like every Q in the universe, we have to calculate it by gamma multiplied by a height, right? How do I find this height? This height is basically given as Z1 equals B, right? But the problem is I have to even consider the 1.5 that is above as well, the depth of the foundation. So it's going to be what? It's going to be 18, which is my gamma, multiplied by 1.5, which is df, plus, now b, this is z equals b, which is 2.5. This equals 72 kilonewton per meter squared. Now I am ready to draw, I think. Yeah, we are ready to draw. So now we could draw this basically. So basically what I like to do usually is, redraw the whole question so I know exactly what's happening. So I do something like this, and I say this is df, which is 1.5. And I have to do the drawing for ES first, or QC, mind you. Okay, QC. So I have, or ES is better, yeah. Let's go with ES. So I'm going to have something like this. So I'm going to increase first, then I'm going to drop down a bit. I'm basically copying the same drawing as here, yeah. I'm going to have something like this, then I'm going to go down a bit, and it closes as this. And these zones, basically, we did calculate for them. So this is 1750, not 750, it's the ES diagram. So I have to basically put these now here. So 6125, and for this zone, it's going to be 12,075, and I have 10150. Yeah, cool. Now I have some depths I have to take into consideration, right? So I have 0, this is called 0, and this is 2. And I have a point of interest, which is what? 2.5, which is my depth of foundation, equals B. Why? Because the max is there, yeah? Because the max is there, basically. Because as we could see in this drawing, the max is at what? Z equals B. So it's a point of interest. Yeah, and I have my 8, and I'll stop my diagram. Of course, there is more of this, but I'll stop my diagram at 10. But there is more till 14, right? But this is out of my zone of influence. Okay. Now I have to calculate the IZ max diagram. I have to, sorry, the IZ diagram. We do not know how to draw straight lines these days. All right, let's go something like this, So we have something like this. So I have to basically do this, and it's going to be, as we could see from here, it's going to be 0.2. Then I'm going to draw a line to my max, something like this. Then it's going to close at what? 10. Not at this. Not at 14, it's going to close at 10 because it's the depth of my zone of influence. Let's add some numbers to make things pretty. This is 0.2. This is IZ max, basically, which I calculated as, I didn't yet, but yeah, if you plug all these numbers in, since you have this, you plug it here, and we calculated this, and this is given in the question. This would give me 0.6527. So this is IZ max. I could put its value 0.6527. Yeah. Now I have a couple of points of interest as well. I have this, which is gonna be, and I have this as well. So I have multiple things I have to do right now. I'll call this 1, zone 2, zone 3, which this small thing becomes zone 4. And I have to calculate I3 here, I2 somewhere here, and I have I4 here, 0 anyway. Yeah? Okay. Now, given this, I have to calculate stuff that I don't have, which is I2 and I3. I have to calculate them. Yeah, why? Because I'm gonna use the formula at the end, right? Which is this one, which needs this. It needs multiple i's and it needs delta z's, and I already have es's. Okay. Now, to calculate this, basically, I have to calculate I2 and I3. I'll have to basically use the slope equations. So I'm gonna take the first part, this number 1, with number 2. I'm gonna draw them together. So it's gonna be something like this, yeah? Something like this. So it's gonna be 0.2 here. It's gonna go like this, and it's gonna close. So this is gonna be 2.5 the whole length, and somewhere here is my 2. I mean, excuse the, the perspective, but we get the point. 6, 2, 27. Yeah, now I have to calculate this. So now I could say that I2 to the problem, the slope basically of the line equals IZ max minus 0.2 over 2.5 multiplied by 2, all of that plus 0.2. Now, basically it's taking 2.5 over 2, and I'm gonna basically take these values as well into consideration. So it's basically, it's an equation of a slope. I mean, you're engineers, you know what's happening. Yeah. Now, when I calculate this, I2 becomes, since I have this, yeah, I do have IZ max. I have this. It's going to be 0.5621. Yeah, this is I2 now. And for I3, I'm going to take the triangle that's down here, basically. This triangle, 3 and 4. Yeah, this triangle, basically. I'm going to take this triangle. First, I took the trapezoidal thing, then I'm going to take the triangle. So, using similar triangles. So, it's going to be I3 minus 0. Let's draw it. It's going to be something like this. So, I3 will be somewhere here, right? I3, and this is 0.6527 because I'm taking till Z max here. 2.5, it starts. I have 8 here and I have 10 here, all from the drawing here. This is 8 and this is the 10. Yeah. Now I have to basically compare similar triangles, basically. They have the same slope. I3 minus 0 over what? I3. Yeah, minus 0, yeah. Over, or over 10 minus 8 equals 6527 divided by 10 minus 2.5. 10 minus 2.5. So basically I took this height corresponding to its length. Yeah, 10 minus 2.5. And I took this height, basically, I3 minus 0. I mean, minus 0 is not necessary, but yeah, whatever. 10 minus 8, which is its height. So I compared this small triangle with the bigger triangle. I did not, color. So it's going to be I3 equals 2. Well, we do the math. It's fine. So this is 2, right? This is 2 multiplied there. And you're going to get basically I3 as 0.173 when you do the math. Yeah? So now I have I3 and I have everything basically. Now I'm going to draw a final drawing basically. Same thing. I'm going to do this. 0.2 again. Now I have, this is IZ max, for example. This is going to be I2, which equals 0.5621, and I have 0.6527, sorry, 27, and I have I3 somewhere here being 0.1, sorry, 173, and I have all these zones, right? This is at, everything has its own height, so this is at 0, and this is going to be at 2, this is going to be at 2.5, this is going to be at 8, and this is going to be at 10. Yeah, now I have to draw a table. Yeah, I have to draw a table, a nice table. Basically, I have to calculate some values now. Yeah, this is the ES IZ average. Yeah, so this is gonna be layer, this is gonna be delta Z, this is gonna be ES, this is gonna be IZ average, and this is gonna be IZ ES delta Z. Okay, so we have 4 layers, right? 1, 2, 3, and 4. So for layer 1, 2 minus 1 is 2. ES we calculated as 6125. We could take it from this diagram basically. I average now. Now I average is basically going to be this plus this over 2. So it's going to be 0.5627 plus 0.2 over 2, which is going to be 0.381. We're taking the average of the two i's, you know, the summation of these over their number, which is 2. Now after I multiply all of these and divide basically and do everything, which is basically everything I have, these 3 values are these, remember? So we have 0.001244. This is layer 1. Now for layer 2, it's going to be 2.5 minus 2, which is going to give you 0.5. And I know from my thing, in the starting from 2.5, what do I have? Or starting from 2, I have this value for ES, the modulus of elasticity. So it's going to be 12,075. And the average is going to be what now? This, which is the max, IZ max, 0.6527 plus 0.5621 over 2. Yeah, which is going to be 0.6074. And you know, we're going to do the same thing here, 0, 0, 0, another 0, because it's a small layer, 2515. Okay, for layer 3 now, which is this one. For layer 3, it's going to be 8 minus 2.5, which is going to 8 minus 2.5, which is going to give you 5.5. And you know, it's the same thing as well, 12,075, you know, according to our diagram, this one. Okay, and it's going to give me 0.413. We plug the numbers, plug and chug as they say, triple zeros, 1882. Now for layer 4, it's going to be 10 minus 8, which is going to give me 2, 101.50. We calculated that before. The average is now going to be what? Yeah, it's going to be basically for layer 4, 0 minus this over 2, or plus this over 2, it's going to be 0.0865. Yeah, 0.001714. Let me check something with the calculator real quick. Yes, 0.0865. I just had to redo this. So you could basically sum them if you want. Sum these. and you get 3.549 minus 4 to the power minus 4. Now I'm ready now to calculate everything. Yeah, I know this is a labor-intensive thing, but that's why it's difficult, you know, and and these slope equations are nasty sometimes. I mean, not nasty, but you know, if you know them, then you know them kind of thing, you know. Okay, but that's how you solve it anyway. There's no other way. All right, so now I'm ready to calculate the coefficients. Remember, now we only took care of this part of the equation. Yeah, let me just clear some numbers. We only took care of this part of the equation. We still have to calculate C1 and C2, right? This we already have. We summed them and everything. Yeah, we summed them and everything. So the sum I calculated is basically going to replace this, by the way. All of this. Okay, back to our problem. So now C1, yeah, C1 equals, as a formula, 1 minus 0.5 Q over Q bar minus Q. We have everything. So 1 minus 0.5, Q is 27. We calculated that at the top of the question. 195 minus 27 again. This gives us 0.9169. We have C2. C2 equals 1 plus, it's the time parameters. It's going to be something with time. 0.2 log 10 years over 0.1, which is basically the formula has this. That's its parameter, T, yeah? Equals 1.4. When in doubt, you check this, basically, yeah? It's going to be what? This is the formula, and this is the other formula. Yeah? Cool. Equals 1.4. Now I'm ready to calculate the settlement. I have everything. So SE, remember, is C1, right? Multiplied by C2, Q bar minus Q, summation from I equals 0 to Z, which is now for us 10, right? Z equals 10. IZ average delta Z over ES. We calculated this, right? Remember, and we have this, we just calculated. So SE now equals 0.9169 multiplied by 1.4 multiplied by Q bar 195 minus 27. We calculated all this, yeah? Multiplied by my sum here that I calculated, 3.549 multiplied by 10 to the power minus 4. All of that gives you 0.0767 meters. You multiply that by 1,000, you get yourself 76.7 millimeters. Yeah, and you're done now. Again, let's review whatever we've done. Basically, I have a question, right? He gives me QC, yeah? He gives me QC, and I know basically that QC and ES are related. How are they related? Because for strip footing, ES equals 3.5 QC. Remember, if he gave you a square footing, you have to basically substitute 2.5, and your chart becomes different. So the second step, basically, after I did the table for ES by multiplying by 3.5 for each layer, I get IZ max. I have to get IZ max. Why? So I have basically to draw this afterwards. So IZ max I have to get, but I do not have the depth of the IZ max. Given in the definition here that Z1, which corresponds to IZ max, which is here, see, is Z equals B. So now I have only to get the other values, I2 and I3. How do I do that? By basically slopes and similar triangles, yeah? After I get all of these, I go into my table. But there is a trick here. I average, which means that whatever you calculated before, you're not going to use it as the same thing, I2 and I3. Now you have to calculate I average for each layer. So I average will basically be somewhere like the I of the average of this layer, the I of the average of this layer, the I of the average of this layer, the I of the average of this layer. So basically you have to calculate 4 averages. And to calculate 4 averages, we have to basically go layer by layer. So I have 4 layers, right? Okay, so for the layer 1, the I average will be I2 plus the initial 0.2 over 2. Yeah, so this value plus this over 2. And I'll do that for the second value, which is going to be IZ max plus I2 over 2. And, you know, it's going to be the same thing for the rest. After that, I basically multiply all of these numbers or divide them through this formula. You get a very small number. You add all of these small numbers together, you get yourself the sum of IZ delta Z over ES that you have in your formula. C1 and C2 basically you could calculate whenever you want to, but I usually like to get the hard things out of the way, then go through the problem. After that, you know, it's basically plug and chug. You have everything and you're done. Perfect. Yeah, but again, you know, like the way I deal with these problems are, you know, usually because they're long and labor intensive and, you know, there's mathematics and stuff, I usually see what, from the first, like, moment I look at the question, I take my givens, I see what I'm missing. I see that I'm missing this means I have to calculate them, and I'm missing this, but I have this and I'm missing that. So basically I start basically numbering them, or, you know, in the order I'm gonna do them and stuff like that. So basically this is your formula. You do what's missing. That's my take, basically. That's how I usually do things with these long problems. I see the formula, I see what I'm given in the question, what information I'm given, and I'm just gonna have to plug these numbers at the end, right? So I calculate them. So I took the hardest terms first, then I went through the smaller ones. And that is it. You know, it's a very labor-intensive question, and, you know, I'm not gonna lie, it's not easy because, you know, you're gonna make maybe calculator mistakes and stuff like that. And plus, this is given for a strip footing, yeah? Maybe in your notes, your professors gave you one for a square footing. If so, you know, solve it and, you know, show me and we'll see. That was Schmertmann's method for calculating set.